This video is for 1.5 scientific notation. And scientific notation is used when we want to express very large or very small numbers. It can be used to express any number, but in particular, very large or very small numbers. We express the number in scientific notation with a particular way. So here's the rule. You must use a number p times or multiplied by 10 to a power. And the rule for that p is that p is a number between 1 and 10. And k is the power of 10 that p must be multiplied by to equal the number being expressed. So you may still have the correct number expressed, but if you don't have a p that is between 1 and 10, then you're not specifically in scientific notation. Let's look at some examples. The number 6.873 times 10 to the power of 11 is actually this number here, which means that the decimal 10 to the power 11 is a 1 with 11 zeros after it. So the decimal is actually 11 places to the right. And so instead of being here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there. Okay? So that's when we want to express a very large number. We can also do it with a very small number. This number here, when the exponent is negative, from what you learned with exponent rules, 10 to the negative 6 is equal to 1 over 10 to the positive 6, which is 1 over 1 million, or 1 millionth. So the value 5.67 is actually multiplied by 1 millionth. And so the decimal is actually 6 places back this way from here. Originally, in the scientific notation form, it sits there, but this converts it to 6 places to the left of there. 1, 2, 3, 4, 5, 6. Now, since p, this is the p value, p must be between 1 and 10. You will always see one digit to the left of the decimal and any other significant digits to the right. Check to see how your calculator can express numbers in scientific notation and perform multiplication and division with numbers that are expressed in scientific notation. So you are looking for one of these buttons, EXP or EE. So let's take a look at entering the number 3.25 times 10 to the 11 on the calculator. And right here is the scientific notation button on this calculator, EXP. And so when you enter that button, you're telling the calculator to multiply whatever number you put in by 10 to whatever power you include after. So I'm going to enter 3.25, and I would like you to focus on the calculator screen, 3.25. And now we will hit the EXP button. So the calculator shows an E, that is, we are multiplying by 10 to the power. So that E is actually this part of the expression. Now we must tell it what power, 11. Okay, and so we could actually multiply that number by let's just multiply by 2.00 times 10 to the 3. Okay, so we're expecting 3.25 times 2, or 6.5, and we would add the exponents. It will be 10 to the 14 when these get added, right? So let's just do that on the calculator. So that number times 2.00 exp 3, and we'll see what it equals. 6.5. The calculator says E14, so that means you don't write it this way. You write 6.5 times 10 to the 14. All right, so I encourage you to take a look on your calculator and find a scientific notation button. It could be EXP, it might be EE. You might also, if you don't have that, then you might just have a 10 to a power, which is the second function of the log button. So that will work as well, but you must practice with it and see how your calculator works. All right, so it's good to be able to do this with or without the calculator. Doing it without just shows an understanding, and doing it with means that you'll be able to perform many complex operations involving numbers in scientific notation. So just for practice, and I maybe don't use the calculator for this part, pause the video and express each of these numbers in scientific notation. So to begin with, 364.35, if you recall from significant digits, that has 5 significant digits. We want to still express the same number of significant digits, but we need our p times 10 to the k, right? The p value will be a number between 1 and 10. So where can I place my decimal in this number so that it is between 1 and 10? And that will be right here after the first significant digit, 3.6435. If I place it after the 6, then it's not between 1 and 10, it's 36.435. If I place it before the 3, it's not between 1 and 10 because it is 0.36435. So we place it after the first significant digit always. So 3.6435. Now, what power of 10 should we multiply that by so that it actually expresses this much? And so we take a look and say, well, this has to actually go 2 places to the right. And so that is by multiplying by 100, or 10 to the power 2. Looking at the second one, the decimal, instead of being here, to be a number between 1 and 10, for the correct way to express p, it should be here. And now, so that's 4.73. Well, that's not the same as this. We need to multiply by the appropriate power of 10 to actually express this value. So it actually needs to come back 1, 2, 3. So 3 places to the left. Left means I better throw a negative in front, because I'm making the number smaller than 4.73. So we want to use the negative exponent. All right. And then there are the answers for the other 2 with very similar explanations. Okay, now going the other way, practice writing these numbers in ordinary notation or standard form. Right now they're in scientific notation. Write them without this power of 10, okay? Pause the video, give that a try. So 2.4 times 10 to the 6, that means the decimal should be 6 places to the right. One of those places is used up with the 4, so it's 2 4, 0, 0. All right, we've gone 1, 2, 3, 0, 0, 0, 4, 5, 6, and lands here. 1.56 times 10 to the negative 4. It's going this way 4 places. 1 is used up by the 1, so 0.000156. Let's double check. Going from here, 1, 2, 3, 4. I always place a 0 in front of my decimal. That's just so that the decimal doesn't get lost, really. It's not required. 6.3 times 10 to the 3 will be 6300. The decimal has gone from here to there. And 1 times 10 to the negative 5. Well, the decimal is actually here, right? 5 places left will give us 0.00001. Now a comma is often used, that's really just to help us read the number. It's not necessary. So commas go every 1,000. And I know this is not done in all areas of the world. Sometimes commas are used for decimals. So if you are a person that normally that decimal would be a comma, you're going to have to watch it. Here we use a dot, not a comma. A comma is for dividing up the thousands to make the number easier to read. Try this now with your calculator. Assume that you cannot put all these zeros in your calculator. Try expressing it in scientific notation. And, actually, it says here without the calculator. We're going to go without the calculator, using the laws of exponents. So expressing in scientific notation first, and then using the laws of exponents to simplify the answer. So this decimal sits here. Well, 5 places to put it between 1 and 10. That will be 3.6 times 10 to the 5 times 2 times 10 to the 6. So since it's all multiplication, I got multiplication there, multiplication there, multiplication there, multiplication is associative. We can rearrange it and do it in any order we like. So let's multiply the two values between 1 and 10 first. 3.6 times 2 will be 7.2. And then we can multiply 10 to the 5 times 10 to the 6. And if you recall back to the rules for exponents, so this you could do in your head, right? This you can now do in your head because we are multiplying with the same base. We add the exponents, it becomes 10 to the 11. 7.2 times 10 to the 11. And it's still in scientific notation because this p-value is still between 1 and 10. If it wasn't, it would need an adjustment. Now that you've done that by writing it out, also check it with the calculator as well. Okay, on your calculator with the scientific notation button, practice these. Pause the video. All right, so back at it, we are multiplying whenever bracket is side by side, so we can key this directly into the calculator with the EXP or the EE button. Remember with those, you don't put the base 10 in. You should be getting 2.8 times 10 to the 28. And I am writing my answers with the same number of significant digits as the original question, 2 in this case. 2 significant digits, let's write it like that way. This one will have 3 significant digits. And we have to add negative 11 and negative 9. And this number will not be between 1 and 10. It was higher, so you must bring it back to a number between 1 and 10 and reduce the exponent. Let's take a longer look at that one, okay? If we multiply 5.34 by 7.36, it's 39.3024. That's what the calculator says. Let's just stop that at 3 significant digits, okay? 39.3. And if we add the exponents on the 10, we get 10 to the negative 20. So actually, this decimal is really 20 places that way, right? So I want to still express this in scientific notation, so I must move the decimal to make this number between 1 and 10. So I'm moving it this way. So it came from here to here, which means now it's only 19 places away. So that's why it becomes a 19. Now the last one, 2.8 times 10 to the 8, and it's divided by, in case you hadn't noticed, 1.4 times 10 to the negative 8. So now if I do 2.8 divided by 1.4, that's equal to 2.0. And then I do my 10 to the 8 divided by 10 to the negative 8. The rule for division is to subtract the exponents. So this becomes times 10 to the 8 subtract negative 8. And what does that do? 2.0 times 10 to the 16. Okay, so I suggest some practice from 1.5. Again, I'm listing a lot of them. Please don't feel like you have to do them all. Do some practice until you're comfortable with that, comfortable doing it by hand, comfortable doing it with the calculator. And that should be sufficient. Bye now.